So mental computation has been defined as the ability to calculate exact numerical answers. Okay, so this is the keyword here. Okay, mental computation has been defined as the ability to calculate exact numerical answers without the aid of calculating or recording devices. That means you do everything mentally. Of course, if the mental calculation is quite long, you can record down the answers lah. Okay, so mental calculation is most used in daily life. Okay, when we go out, the calculations that we see in daily life, we usually solve it using mental computation. It saves time doing calculation. That's why it's important for students to learn mental computations. It's important for teachers to encourage students to think of mental computations anytime they're in a situation where they need to do calculations. Okay, mental computation also produces exact answers. Fluency with mental computation is a prerequisite for estimation. That means if students want to be good at estimation, they must be able to do mental computation very well. Okay, so there are several strategies for mental computation. Okay, all the strategies that you learned that you use to think or to learn basic facts of operations like addition, subtraction, multiplication, division. All the thinking strategies are all strategies for mental computation. Okay. Other than that, we have a few other strategies for mental computation. Okay. Okay. The first one that we're going to look at is first strategy. Okay. Okay, so as I told you just now, all the strategies that we use for learning basic facts are all mental computation strategies, because basic facts we teach them how to memorize. Okay, so to add on to those strategies or to reinforce those strategies, because those strategies earlier we used only for single digit numbers, so now we can use this for any calculation. Okay, so the first strategy is count on and count back. Okay, we can count up or count down by count back, count down by place value. For example, if we want to do this calculation, 352 minus 3, we can always count back 351, 350, and 349. We don't need to use a standard written algorithm, or we don't need to use a calculator. Straight away, you just count back in your mind, count back 3 steps, and you get your answers. Okay. Another example, 256 plus 30. Okay, so we can count on. So 256, we want 30. So 256, 266, 276, 286. That's your answer. Okay, so we have count 1, 2, 3. 3 tens. Count on in, we have counted on in tens. Okay, 1455 minus 200, 1455 minus 200. Minus will be count back, addition will be count on. So starting from 1455, okay, starting from 1455, we go back to 1355. We're going back in hundreds, so it's 1355. 100, go back another 100, 1255. Okay, so 1, 2. We're going back in hundreds, so we reduce the hundreds each time by 1. So our answer is 1255. Okay, this is count on and count back strategies that we need to teach the children. So when they see an example like this, straight up, because it's an easy number, okay, and they can easily count back and count on. They don't have to use a calculator, and they don't have to do it using pencil and paper. They don't have to write down and do. Okay, so they need to learn to do it mentally lah. Okay, that's the first strategy. Okay, second strategy is we're going to choose compatible numbers. Okay, second strategy is choosing compatible numbers. Okay, so for this strategy, we select pairs of compatible numbers. Compatible numbers means numbers that are easy to compute mentally, to perform the computation. Okay, So for example, number one, we want to do the 715 plus 67 plus 15. Okay, so we know the mental computation is exact answer. So we cannot round it. We cannot do any pembundaran here. Okay, so we want to select them. So we know that this number and this number look easy to add. So we add that first. Okay, so 715, 730. Straight away we got 730. Then we add on to 760, sorry, 67. Add on to 67. So 30 and 60 is 90 already. So 797. Okay, this is compatible numbers. Okay, second example, 4 times 11 times 25. You look at the numbers and you see that this number and this number are very compatible. Okay, so you know that 4 times 25 straight away is 100 times 11 is 1100. Okay, and one more example, 63 plus 18 plus 27 plus 12. Okay, so we look at the numbers, we can see that these two numbers are compatible. Okay, these two numbers are compatible and these two numbers are compatible. That means compatible means they are easy to calculate. Okay, so 63 and 27, we know 60, 70, 80, 90 already. 90 plus 18 and 12 is 10, 20, 30. So this is 120. Okay, so this is using compatible numbers, selecting compatible numbers strategy to calculate. Okay, so when you see a calculation, you look at it and you think, can I use compatible numbers or is it better to count on, count back? Okay, okay, so the third strategy will be left to right strategy. Yeah, left to right strategy, also known as use place value strategy. Okay, we're going to use place value. Use place value strategy. Okay, for this strategy, we break apart the numbers into their place values. This we are doing it mentally actually. Okay, break apart the numbers into their place values and then perform your work from left to right. Okay, so for example, the first one, 3, 4, 5 plus 1, 3, 0. Okay, so actually this is 300 plus 40 plus 5 and this is 100 plus 30. So we're going to add the hundreds first. So 300, 400, 40 plus 30 is 70 and then we have a 5 here. So it's 375. Okay. So similarly for 232 times 4, we have 200 plus 30 plus 2. This is times 4. So we know that 200 times 4 is 800 plus 30 times 4 is 120 plus 2 times 4 is 8. So this is 928. Okay, so we are not writing this down. Okay, none of this we are writing down. We are just doing it in our mind. Okay, we look at 345 and we know this is 340 and 40 tens, 4 tens and 5 ones. So we add the hundreds first, then we add the tens, finally we add the ones. So we are adding or multiplying or dividing according to the place value. Okay, so that is the third strategy. Okay. Fourth strategy is to use compensation. Okay. Fourth strategy is to use compensation. Okay, we're going to substitute a compatible number for one of the numbers so that you can complete the computation mentally. Okay, so actually this is very subjective. Different children can do it different way. Okay, so 65 plus 35. If this is difficult to calculate, then we can change these numbers. We can change maybe one of the, usually for compensation, we try to change only one number. Okay, so 65 plus 30, or we can change 38. we want to make it easy to calculate, we straight away change to 35. But this is less than 38, so we need to add another 3. So we know 65 plus 35 is straight away 100, and then with the 3 there is 103. Okay, so this is compensation. Compensation is when you substitute one of the numbers into a compatible number. Okay. Okay, another example will be 19 times 6. 19 times 6, if 19 times 6 is difficult to do, we change this to an easy number, 20 times 6. We know that 20 times 6 is one more group of 6, okay? If this is one more group of 6, we have added on one group of 6, then we must minus one group of 6. We must minus one group of 6. So 20 times 6 is 120, minus 6 is 114, okay? Again, just to stress and tell you that all this is done mentally. Okay. And maybe one more example, 908 minus 39. To make it easy, we can use 900 first. 900 minus 39 or 900 minus 40. But instead of 908, we use less 900. That means after we do this, we need to add on another 8. And because we have minus more 40, we also need to plus another 1. So 900 minus 40 is 860, plus 8 plus 1 is 869. Okay, so this is using compensation to calculate mentally. Okay, it is good for students to go through all this so that when they see a mess, they can straight away do it mentally. Okay, they must learn all the different strategies. Okay, we have one more strategy, that is equal additions strategy. Okay, equal additions strategy. Yeah. Okay, since the difference between two numbers does not change if the same number is added to both of the original numbers, we select an addend that will transform the subtraction into a recognizable difference. This means that okay, let's look at this example first. So say we want to do this 1456 minus 397. Okay, so if we add a number to both of these numbers, the difference doesn't change, correct? So if I feel this is difficult to do, maybe I want to make this into 400, I can add 3 to this number, right? If I add 3 to this number, then I should add 3 here also. Okay, so if I add 3 to both the numbers, then the difference will not change at all. Okay, so if I added 3 here, this will become 1459 minus 400. So now I can minus the 400 straight away. I have 1059. Okay, so this is the equal additions method. Okay, this one, maybe another one. 145 minus 77. If I want to do it fast, I can add 23 here. I can add 23 here. Okay. I can add 23 here. So this will be 168 minus this will be 100. So I minus 100 here. I will have 158. Okay. Oh, sorry, I have 68. 68. Okay. So this is the equal addend strategy. So any questions so far? So for mental computation, we have looked at 5 different strategies to compute mentally, other than all the thinking strategies that you have learned earlier. Okay, so any questions?
Madam, I have one. So we can use the whole strategy in any type of solution, any type of question that require our computation.
Yes,
Yeah.
you can use any strategy, but some strategies are, you look at the problem, the calculation that's given. Okay, If it's like a big number and a very small number, you can use count on easily. Okay, you have to look at the numbers. Okay, the numbers will tell you which strategy to use. Actually, you can use any strategy lah. But as you do more and more, when you look at it, you will know which strategy to do already. Okay, that's why practice is very important. Mental calculation must be taught to the student. They cannot do if you don't teach them. Okay. Okay, so we have finished with that. Now we're going on to estimation. Okay. Okay. Estimation. Estimation is essential when using a calculator or performing a more difficult paper and pencil computations. Okay. I don't know about you all, but before, when we learn computation in school, we have to estimate first. You have to do the estimation first, and then only the teacher allows you to calculate. Okay. So although it is quite tedious, it takes, not everybody like to do that. Okay, but it's very, very necessary. Okay, estimation is a very important skill and must be taught, especially when you work with money, decimals. It is very important to teach children to estimate first and then only calculate. Why? Because estimation is an important life skill. Most of the day-to-day computations we use require an estimate rather than an exact answer. Is this true or not? In your daily life, when do you do estimation? When do you use estimation to calculate? Can you give me some examples? You never use estimation? When you go to the supermarket, don't you use estimation?
Yes.
Yes, isn't it? Because sometimes you carry maybe 100 ringgit and then you buy things and you're not sure whether you have enough money, right? When you reach the counter to pay. So you must estimate, isn't it? That's, I think we all use estimation when we go to buy things in the market or supermarket or somewhere. Okay, we want to know if we have enough money to pay. We always overestimate up so that we have more than enough, not less. Okay, so estimation is a very important life skill. The two computation that we use in daily life is estimation and mental mathematics. We use that a lot in daily life. We don't go out and take out a calculator or maybe a pencil and paper and calculate, oh, how much is this, how much is this. We don't do that. We straight away estimate. Okay, this we round up and we estimate. Okay, so estimation is an important check on computation. Okay, when you want to check whether your answer that you calculated through an algorithm is correct or not, you use estimation. Actually, the correct procedure is to estimate first and then calculate. Okay, you always estimate first. Okay, you get a value already and then only you calculate. And when you get your answer, you check with the estimation. If it's near to your estimation, then you know it must be correct. Okay, so estimation will also identify significant calculated errors, such as keying in wrong numbers or the wrong operation. Okay, especially when you're keying in a lot of numbers, you need to estimate first so that you know if you have made a mistake, if you've keyed in the wrong number. Okay, for written computation, significant place value errors are highlighted by estimation, especially when you're doing decimal. Okay, when estimating, learners are more involved mentally. Okay, so that is why we encourage learners to do estimation. Okay, estimation also, there are several strategies to do estimation. Okay, first strategy, front end truncate. You know what is truncate? I think you've seen this word before when you studied your geometry paper, right? What is truncate? Anybody? You don't remember this word truncate? Truncate means cut. Cut, huh? When you cut something, you cut a solid, that is truncated solid, right? So that's truncate. Okay, so when you have, say you want to add numbers like this, say you want to add numbers like this, 8,857 and four numbers say you want to add, and you want to just estimate, so you truncate. We call this truncate front end. You just draw a line after the first digit and the other digits all replaced by zero. Okay, So this is cutting here, you're cutting here. So you just add the first digits. So when you add the first digits, of course, you can do compatible numbers here, 10, 21. So you have 21 and you have, and so this estimation for this calculation is 21,000. Then you use your calculator or your algorithm and you calculate and your answer must be around here. Okay, so this is front end truncate. Another example, say you have numbers like this that you want to add. Okay, these are decimal numbers and you want to add it. Okay, but before you add, you want to estimate. So to do a quick estimation, you do a front end truncate. Okay, so you know this is all 0, 0, 0. So 7, 11, 12, 13. Okay, so your estimation is around this much. Okay, another example, you want to minus 1689. Also, you can truncate this, so it will be around 7,000. Okay, or if you want to use it for, say, fraction 1/8 times 3 2/5, you can truncate here. Just take 4 times 3 is equals to 12. So your answer is around 12, about 12. Okay, or if you're doing an if you're doing a addition of fractions, 4.5 plus 7 1/3 plus 9 1/3. Okay, you can truncate this, just add the whole numbers, 4 plus 7 plus 9, so this is 20. Okay, this is front end truncate, easy estimation. Okay, any questions for this? Okay, second
This is
strategy.
just for, madam,
Yes,
that's for
yes,
just for estimation, right? Not for the real answer.
no, only estimation. Okay,
Okay.
because before we ask the student to calculate, we want to teach them to estimate. Okay, so that students know whether their answer that they calculate is reasonable or not. Okay, okay, so we're finished with that. Okay, second, okay, second strategy for estimation is flexible rounding. It is rounding actually, but it's flexible rounding because that means you can change. You don't have to follow the rounding rules strictly. Same example like this, same numbers here. You have 4 numbers that you want to add. So the first number, 8,857, you round it to 9,000. Second number, 4,758, you round it 4,000. Third number, 7,000, and you add it and you get your answer. Okay, or you say you have a problem like this, 68 plus 51, you can round it to 70 plus 50 and straight away find the answer. You have 314 plus 475, you can round it to 300 plus 500. You can even, it's up to you, you want to round to 500, or if you want to round to 400 also okay. But as you do the practice, you know which numbers will be closer to the actual one. Okay, so that's why they call it flexible. You can round up or you can round down. You don't have to follow the rounding rules. Okay, so if you have an example like this, 44 times 44, how much is 44? And you want to estimate the answer first before you calculate. So you can round this straight away to 40 times 40, which you can get the answer very quick. Your actual answer is 1936 if you use your calculator. Or you can round it up to, because this is 44 and you think, oh, this 44, it is more than, it is another, almost another 10, so you can round it to 40 times 50, you will get 2,000. Okay, so when you write your estimate, you should write your estimate is either less than or more than, so you should write your answer less than 2,000, or you should write here more than 1600, because here you are rounding down, so you're taking less, so that means your actual answer will be more than, but here you're taking up, So you can write there less than 2000. Or if you're not sure, then you just put here, sorry, you can't put an equals, you put like this, okay? You use this answer, approximately equals to 2000, okay? So this is flexible rounding. That means you can round down or you can round up. You don't have to follow the rounding rules. Rounding rule says more than 5, you must round up. Less than 5 or more, you round up. Less than 5, you round down. Okay. So in this case, you don't have to follow the rounding rules. Okay. That is the second strategy. Third strategy is clustering. Clustering, we use clustering to estimate the sum of several numbers that are close to one value, okay? Say you have all these numbers and you want to estimate the sum of all these. All these are weights given in pounds, okay? And you want to estimate, you look at these numbers, even if you don't do this part, is okay, okay? Even if you don't do that part, it's okay. But you look at all these numbers, 21.5, 19, 18, 22, 20, you see that they all around 20, they all cluster around 20, or the average is around 20. So you take 20 as your cluster, and you know there are 5 numbers, so it's 20 times 5, or 20 you add 5 times, so you get 100, okay? So all these numbers sum up to about 100 pounds. This is called clustering, okay? Okay, and I'll give you one more example. If you have several numbers like this, 82 plus 90 plus 87 plus 97 plus 94, okay? You have 5 numbers and you want to estimate very quickly what is the total. You look at the numbers and you see that they are all average is about 90, okay? They all cluster around 90. That means they're all very near to 90. It's very, very near to 90. And there are 5 numbers, so the total must be about 90 times 5, which is 450. So you estimate that this total is about 450. Okay, this is called clustering, using cluster. When you have a lot of numbers close to one value, then you use this technique. Okay, and the last strategy, we have 4 strategies for estimation. Sorry. So the last strategy is compatible numbers. Okay, so in compatible number strategy, we estimate using compatible numbers which are close to the actual numbers but easier to solve. Okay, so we are just going to estimate only. Okay, so supposedly we were given the first one, we change this to compatible numbers because we want to divide this number. We cannot divide easily, but we know that 603 is compatible. 6 and 3 is compatible, so we change this to 600,000 and this to 300 because 6 and 3 can divide evenly, so we know they're compatible, so we change the numbers. Okay, so these two numbers, they're not compatible, so we change them to 920. Okay, it is compatible because they are all multiples of 10. 73 plus 28, not so easy to add, but if we change the 28 to 25 and 73 to 75, these are compatible numbers, easily added. So we can just, and they're not very far from the original. 32 and 48, both of these numbers are already compatible, okay? Because then you can easily add the 8 and the 2, so they're compatible. 114 minus 35. 35, you want to minus from 14 a little bit, 4 minus 5 a bit difficult. So we change the 35 into 34. So straight away 4 minus 4. 72 minus 54, difficult to minus the 4. So change the 54 to 52 and straight away you get a estimate here. Okay, that is one example. This is the other example. 545 divided by 8 cannot divide by 8, so we change to a compatible number that can divide by 8. So change 545 to 560, which you can divide into 8 evenly. 317 and 7 not compatible, so compatible with 7 is 280. 256 divided by 3 difficult to divide, so we change to 240, which we can divide easily. Same thing, all this lah. Okay, so this is use compatible numbers strategy. Okay, so for estimation we have 4 strategies. That is the front end truncate, which is the easiest strategy, but sometimes you don't want to use that strategy. You can use other strategies like flexible rounding, also very easy to use flexible rounding, or clustering. If you have a lot of numbers and they're all near each other, then use clustering. That's the easiest for that kind of data. And lastly, we have compatible numbers strategy. Okay, so you need to know all the strategies and the examples. Okay, so our last, okay, before we move on, I think we have some. Okay. Okay, I will do that later. Okay. Okay, we're going to go on to the last topic, which is calculator computation. Okay, so is calculator allowed in primary school? Do we use calculators in class in primary school?
No.
No.
We don't use them in the exam, but we can use them in the class. Okay, we can take the calculator to the classroom. You can teach using the calculator, but the student is not allowed to use the calculator in the exam. Okay, but nowadays a lot of students use calculator at home to finish their homework. Okay, which of course is not encouraged lah. So calculators can be used for 2 purposes. Okay, a calculator can be used as a computational device. That means just to calculate. Okay, especially when it is used to perform difficult calculations as part of a mathematical activity or problem solving. We cannot ask the student to use calculator to calculate basic facts or to do their standard written algorithm or any other algorithm. They cannot use the calculator to check answers, cannot, okay? But if you're teaching them problem solving and your objective is the problem solving process, and the problem solving question has a lot of big values, then you can ask the student to use the calculator to calculate the computation. Okay, because the objective is not the calculation but the problem solving process. Okay, so calculator can be used as a computational device if the calculations are very difficult and the goal is problem solving. Okay, and the other reason for using calculators is as pedagogical purposes. A calculator is being used as a teaching aid for pedagogical purposes. That means for the sake of teaching, when it is being used to specifically introduce or extend a child's understanding of a math concept. That means we use the calculator to teach math concepts. So you can use the calculator. So calculator in the classroom we use for 2 purposes. One is to teach any concept. The other thing is to calculate very difficult calculations involving problem solving. Okay. Okay, let's look at advantages and disadvantages of the calculator. Okay. Okay, can you give me some advantages and some disadvantages of a calculator? Anybody?
Fast calculations.
For advantages, is it?
Yes.
Fast, okay, fast computation and compute answers very fast, okay. Anyone else?
Easy to use.
Easy to use. In what way easy to use? Easy to press numbers or what?
Yes, press numbers.
Okay, easy to use also comes inside here, okay. Fast computation, okay. Okay, we can put easy separately. Easy to calculate, okay. What else?
Not encouraging brain development. I mean,
That's for
for
disadvantages,
simple.
is it? Is it for here?
Yes. Yes.
Does not
Disadvantages.
encourage uh, mental development, okay. Okay, what else?
Expensive.
Expensive. Where is it? Disadvantage, How much is a calculator nowadays? Anybody has any idea?
Above 50.
50, is it?
Above it, I can't remember.
Oh, so expensive. Okay, that is your scientific calculator, right? Okay. Okay, what other, this good, this is true, disadvantage, because you also need batteries for the calculator, and the batteries wear out, so that's why it's expensive also. Okay, any more? What else is good about calculators? Okay, it's good because it allows children to work with large numbers. Okay, if the numbers are very big, then it's good to use, it's better to use a calculator. It allows children to work with real data, okay? Data that they collect to maybe when they learn data handling, they collect data from other people and then they can work with the data using the calculator, okay? They can explore patterns, okay? Calculator is a very good tool to explore patterns, okay? And it introduces children to simple programming. Yeah, is this true? How does it introduce children to simple programming? Okay, I'll show you this later, okay? And then it introduces children to decimals and so on, okay? But using calculators has also some disadvantages, okay? Like it does not encourage mental development, correct? It's very expensive, and it also discourages children from memorizing basic facts, okay? Because like 8 times 7, what's 8 times 7? Straight away they press the calculator to find what is 8 times 7. They don't want to waste their time trying to memorize it, okay? So that is really bad, okay? And it develops a reliance on the calculator, Any small calculation, straight away take the calculator. I've seen a lot of students doing this also, okay? Simple calculation, already bring out the calculator, okay? So this is not good, okay? And you can easily press the wrong key. You can get wrong answers, okay? If you're not careful, okay, by pressing the wrong key, so you can get wrong answers, okay? So this is one disadvantage. And when you make mistakes, okay, when the child makes mistakes, not able to identify, okay, they don't know where the mistake is because there's no process, no working, so they don't know where the mistake is, okay? So these are some of the advantages and disadvantages of the calculator. But although we have quite a number of disadvantages, if we use the calculator for the right purpose, that is for pedagogical purposes and for problem solving, then it is very it is an advantage. Okay, we should use calculators in the classroom lah. Okay, so let's see how we can use calculators in the classroom. Okay. Okay, so supposing we want to teach about the topic area, we're teaching about areas, and you want the student to tell you which you think is the biggest rectangle, and if you give them a problem solving question like this, okay, which is the biggest rectangle, the first thing that you can ask them is to do estimation. Okay, the student can estimate which is but they can estimate, okay, what is the length of this 1, 2, 3, 4, 5, 6, 7, maybe 7 centimeters, and this one maybe 2 or 3 centimeters. So maybe this is 21 square centimeter. This one 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. 7 times 4 is 28. 28 square centimeter. This one could be 1, 2, 3, 4, 5, 6, 1, 2, 1, 2, 3, 4, 5, 6. Maybe this is 36 square centimeters. So this is the estimation. Okay, we can ask them to estimate, and then later we ask them to measure and calculate. Okay, so because when they use ruler and measure, the dimensions are going to be in decimal numbers. Okay, so they could probably get like 4.7 centimeter times by 3.9 centimeters, something like that. Okay, so it's difficult for them to calculate, or it's going to take time, because the goal of this problem solving is to find which is the biggest rectangle, not to actually solve the calculations. And maybe you have many rectangles, so they need to measure and to calculate. For this purpose, they can use the calculator. So they use the calculator and they calculate the area for each different rectangle. Maybe you have a lot of rectangles, A, B, C, and so on. They can calculate all the areas, and then they can discuss which is the biggest rectangle and why. Okay, so this is like a problem solving question. Here we need to use estimation, and we can use the calculator. So the calculator here is as a tool only, a computational device only. Okay. Okay, another example where we would use a calculator. Okay, say we are teaching the topic data handling topic. So this under statistic. So say the student has collected all this data for some question that you gave them, and now they want to add all this data because there's a lot of numbers to add. Okay, so maybe when they're doing data handling, you want them to go through the process of first they collect the data, and then find some calculations, statistical calculations, and so on. So the idea is not to focus on the addition itself. So when they have a set of numbers like this, the first step is always to estimate. Okay, when you ask them to use the calculator, you must tell them to estimate first. After they estimate, then only they key in all the numbers in the calculator and they calculate. Key in all the numbers in the calculator and they calculate, check with the estimation. If it's close to estimation, hopefully it's correct. Okay, so this kind of when they're dealing with a lot of numbers or large data or real data, then it is okay to use the calculator. Okay, and another use for calculator is when you're teaching concepts. So just now those two activities, calculator was used as a computational device. Here we are using calculator as a pedagogical device. We want to teach them say concepts. Say we want to teach them the concept of counting on. Okay, so you take out your calculators, everybody please, and do it together with me. Okay, so we want to count on from 23. How do we teach them that on our calculator? How do we teach them to count on from 23? What do they have to press first? Count on from 23, that means what? 23, 24, 25. We want them to count on, okay? 26, and 27 and all. That's counting on going forward. So if you want to use a calculator to teach counting on, what do they need to press on the calculator? First, they need to press,
23
okay,
on
23, then
+1
plus 1, okay, and then,
equal
okay, and then,
equal again.
yes, correct. You keep on pressing equal, equal, equal. So 23 plus 1, you get 24. When you press equal, you get 25. You press equal, you get 26. You press, it keeps on adding 1 each time, okay? So we can teach them counting on. We can tell the child, okay, count on from 24. And as they press equal, they must read loudly. 25, 26, 27, 28. Okay, and they can even do this in pairs. What if you want to count on from, okay, later. So what if you want to count back from 45? So how do we do that? 45 minus 1 equals. 45 minus 1 is 44. Okay, so we have 44. Then you press equals again, you get 43. So all you have to do is press equals and keep on going. So as the child is doing that, they can see the number is going down and they can say the numbers loudly as they press the equal sign. 44, 43, 42, 41. Okay, so this we're using the calculator as a pedagogical tool to teach counting on and counting back. Okay, so we want to teach skip counting. Okay, this is very good to teach on the calculator. Say we want to teach skip counting in fives from 20. So we start from 20 plus 5. Press equals. What do you get? 25. You press equals again, you get 30. You press equals again, it goes up, correct? It goes up by 5. Are you trying? Okay, you try this. Say you want to skip count in fives from, supposing you give them, you don't give them 20. 20 is quite easy. You give them 23. Okay, skip count in fives from 23. So they press 5 and then equals, equals, equals. They can do this in pairs. One child can say the skip counting in 5, say 23, 20. The other child can use the calculator and press equals and check if it is correct. Okay, then they can reverse their roles. Okay, so when we do it like this, here we are teaching the concept of counting on, counting back, and counting, skip counting, using the calculator as a teaching tool. Okay, so here the calculator is used for pedagogical purposes, and it's a very good teaching tool for teaching this concept. Okay, so can you see the difference in the way we use the calculator?
Yes.
Okay, I give you one more example. Okay, so if you want to teach estimation, say you want to teach estimation, so you can give them a table like this. You can give, say, the first row here. There are 6 numbers here. Ask them to estimate the answer first. So probably they will estimate this is maybe 50, 80, 60, 20, 70, 40. Probably I think this is it. So 100, okay, 200, 200, 320. Okay, so when we add the numbers, you see we're using mental mathematics to add it, okay? And we're using compatible numbers to add it, okay? So we got 320. If you then use the calculator and ask them to find the actual answer. So if it's nearby, they have put it in correctly, then they can compare the answers and see if they have estimated well. Maybe their friends might have a different answer, and from there we discuss techniques of estimation. Okay, this is another way of using calculators. So calculator is not a bad thing. It is actually a good thing if you use it properly. But if you see the child using a calculator to check the answer or to do algorithm, you must stop the child immediately. Okay, this is then another way to use calculators for problem solving. We are just concentrating on the process, same like just now. A rectangle, you have 2 big numbers here in decimals, and the child is given the area and one side, and they ask what is the perimeter. So to find the perimeter, they have to divide the area with one side, okay, find the other side. Once they find the other side, then they have to add the numbers to find the perimeter. So this is complicating. It's quite complicated and quite long. If our objective is just to learn about area and perimeter and the relationship about area and perimeter, then these calculations all we can allow them to do on the calculator, so that they don't have to waste so much of time with the calculations, because we only want to teach relationship between area and perimeter, okay? But if you're only teaching computation or you want them to add, then of course you can't ask them to use the calculator.